Good morning, folks. So today we're going to avoid making a 4-hour video, and I wanted to show you. In the class I posted an announcement called More Inheritance Examples with a link, and this is a more concise with comments, kind of the stuff that we went over before. And so you see we have, let's look at the code here. We have an interface here. We have a class here that extends that interface, implements this interface. So remember, with interfaces, many different classes can implement it, even ones that aren't related. And another interface. This is, the classes here represent animals and pets. So we have the ability to stroke our pets here. So a class of pet extends the class of organism here and implements the interface iStrokeable. Okay. And we have dogs that extend pet. We have cats that extend pet. So this is very similar to the diagram we had last time, which I should probably take a look at also. So, all right. So it's similar to this diagram. We have, two interfaces. We have, an organism. Here we're calling it animal, but this could be your pet. And then dog and cat classes are extending from here. So as you're working on the assignments, when it asks you to create, an abstract class or interfaces and just extend classes, you can use this as an example and go through and see how it works. All right, I think she heard me say dog. Go lay down. All right. So you've probably had enough on inheritance for now, even though it's kind of the point of object-oriented programming. Make sure you ask questions if you're unsure. If you can do the assignment on your own, that means you understand enough here so that you would be able to move on. If you need help from me, that's fine. Just make sure that you really understand the concepts, and I'm more than willing to help you do that. But we need to move on to chapter 11. And let's just take a look here at the due dates. We're not going to call anyone out, but except myself. All right, we have... Ooh. Today is the salesperson due date, so let's see how many people have turned that in. 2 people, and I think only one person has contacted me for help on this. Actually, 2 people. And we have a total of, oops, let's not show that here. I think we have a lot more than 2 people in the class, so please don't put this off. I do have scheduled 2-hour time slots that you can meet with me to get help or to do advising. So if if you're not experienced with programming, and especially object-oriented programming, even though this is the second class you've taken about it, it's complicated, and you may need help understanding the concepts. Okay? Don't learn this by trial and error. All right. Anyway, it's time to talk about another topic, because you'll be using it in Chapter 11, which the due date is way off here. All right. This isn't due today. We haven't even talked about it yet. We'll make this next week. There we go. I was wondering why there was a gap there. Okay. And so let's take a look at that, and then we'll frame our discussion around the things you'll need for that. And as always, you can make comments in the chat if you want me to talk about anything in particular. If you have questions on the previous assignment, I can show examples and things like that. All right. But I think there's only one person in here. All right, Chapter 11 is about exceptions and handling those exceptions so that we can prevent our programs from crashing. Let's take a look at the exercises. So we're looking at the water temp, which is exercise 2 in Chapter 11. Okay. Let's make sure it's only on this page. Nope, it is. Okay. So it says, argument exception is an existing class that derives from exception. All right. So we know what that means. It's a class that's derived from another class. We just learned about that. You use it when one or more of a method's arguments do not fall within an expected range. So remember, arguments are values we pass into methods. All right, and then the definitions for those methods are in the classes, and they're listed as parameters, so we can use those values in our methods. So an argument exception here is thrown when the arguments, we'll go into detail on this, when the arguments do not fall within an expected range. All right, so you'll create an application. All right, it needs a variable that can hold a temperature, and that should be easy, creating a variable. Okay, within the class, create a method that accepts a parameter for a water temperature and returns true or false, indicating whether the temperature is between 70 and 85 degrees and thus comfortable for swimming. If the temperature is not, it is invalid, and the method should throw an argument exception in the main method. Continuously prompt the user for data temperature, pass it to the method, and then display a message indicating whether the temperature is comfortable, not comfortable, or invalid. All right, so within the class, all right, are they talking about, you could, yeah, throw an argument exception in the main method. I think you could probably do this in the main class with a static method, or you could create a separate class for an object that stores the water temperature and it has a method that takes in a temperature, checks if it's within the range. All right. And then throw the exception. All right, so what is an exception? Well, you know, in every programming class, you know, you should have seen exceptions. So, if you're new to exceptions, you know, it's not as complicated as inheritance, so that's good, even though it uses it. Okay, so we'll talk about what an exception is and how to use it to catch exceptions and prevent the program from crashing. All right. So you've probably encountered these in your programming on, you know, on accident. So when the program does something that you haven't anticipated, okay. So remember, you're the one making the program. You need to consider how it works so that you can catch. Basically, you should be able to know what's going in there. Whatever input you're using or moving values around. C# is nice because it really makes you put a lot of information about what you're using, you know, whether it's a class, creating objects, calling methods. You have to specify the types of your variables, the types of your parameters, and that can really reduce a lot of issues that you would have in like JavaScript or Python. And so with these exceptions, so we can still have these in C#. It's not perfect. Well, it is if you if you write it perfectly, but no one knows everything. So when we have an exception, we have a way to deal with that. It's called exception handling, and it allows you to catch an exception and then either fix the problem or inform the user that they've done something wrong, like entered in the wrong information, and then it can go back and or either continue or go back and try again without the program crashing and potentially losing any data that may need to be saved to a file or to the hard drive. You don't want your program to crash and lose whatever work people are doing. Okay, it says most exceptions derive from three classes: system exception, application exception, and those come from exception. Okay, there are a lot of exceptions, but it helps to understand the parent classes here because there's only three. All right, so let's purposely create an exception so that we can see what happens. So, you know, even a computer can't divide by 0. If you do it, it terminates the program, and we'll take a look at how to handle that to prevent the program from crashing. So let's take a look at the code here. We're calculating miles per gallon. Thank you for that. Okay. Oops, there it is. Close that. All right. So we're taking in input from the user for the miles driven, the gallons of gas, and then it's calculating miles per gallon. So it's using division here. So if someone says they go 0 miles, that costs them 0 gallons of gas, it's going to throw an exception. If you can drive any distance without using any amount of gas, then you're probably driving an electric car. So you might you might have that error if people aren't driving gas-powered car. Anyway, that's going to cause an exception. It will look like this. So here, normal person, 300 miles, 12 gallons. That would be 25 miles per gallon. So you could do better than that. Unless you have a giant vehicle. All right. But what if I get 300 miles with 0 gallons of gas? Well, it's going to give us this message. It says unhandled exception. You did not anticipate this, so we're just going to terminate the program. It says system.divide by 0 exception. So this one, in this case, it's very clear what the problem is. You can't divide by 0. Not all of the exceptions have, easily understandable names. But here it also describes it attempted to divide by 0. Very obvious. And then it tells you which class and method that exception occurred in, so you know where to look. Okay. So we want to, instead of getting unhandled exceptions, either fix the code so we don't get an exception, or we can write a way to handle those exceptions. Okay. So they have these terms here, which if you get into the developer community, you'll probably hear. These are positive aspects of a program: fault tolerance and robustness. If it's fault tolerant, then when mistakes occur or exceptions occur, we have ways to handle them. And robustness really refers to efficiency, so that as the program needs to do more, it's not having to do a lot of extra work accounting for exceptions. And those exceptions aren't causing problems down the line. All right. So in some cases, you can simply use an if statement to check for the error. So how would you solve this problem using an if statement? Let's go back. So take a look at this. We are taking in the two values, and then we're just calculating. And so this line here is where we can have the exception. You could have an if statement that says, if gallons of gas is equal to 0, and I guess you could just do less than or equal to 0, because it doesn't make sense to use negative gallons of gas. Driving 300 miles generates 12 gallons of gas. That doesn't make any sense. So you could have an if statement like that, and then in the else, send a message, then put them back to the input. You can't have 0 or less gallons of gas. So you could use an if statement. All right. That's the, they're calling that, I guess, the traditional method. It's not considered handling an exception. It has very little overhead, so it's not going to cost that much to do that check. So if it's something that's going to happen a lot, you might want to use an if statement. If it doesn't fit these, if it's not a frequent problem, and so if it's not a frequent problem, then you're not going to need to use it all that much. If it is an infrequent problem, it might be better to handle it as an exception. And that allows you, advantage to using exception handling instead of decision making. So it says when a program's main logic is interrupted by a series of if statements and decisions, so filling it up with extra if statements is going to make it longer and harder to read, which is what it's saying here. And you, in this class, you're looking at complicated code every time we're working on this, so it's nice to keep it simple. Alright, so these are the keywords, the reserved words in C# for handling an exception. We have try, throw, and catch. So you can think of it, it's these terms are English that kind of makes sense with what we're doing. You try some code out to see if it has an error, and then you have a way to detect those errors by throwing an exception. And then the catch says, okay, depending on which exception occurred, this is how you fix it. All right. And then the structure here, let's skip down to the structure real quick. So in this case, I guess they don't have any code in here, but they're just showing you how you organize this. So you would put the code that could have the exception inside of a try block. All right, so it's kind of like an if statement or a loop, but you just put the word try here, and then you put it in a block of code using curly braces. All right, and then if that throws an exception, you have a block immediately after that says pass in the exception, and then in here you have code to handle that exception. All right. So the try block is for testing the code while it's running. Catch block, you will need a in this case they're showing you can create you have to do at least one catch, but you can do multiple catch blocks for different exceptions. Okay, so we already saw that. Yes. So this is what it's going to look like. So you'll just put this around your code right here, the try block, and then in the catch block you'll have to add some more code. And this will be easier to identify what this is for instead of just using an if we use if statements in our logic for our program anyway, and we're using them to prevent errors, it's going to be confusing, because is this an if statement for error handling? Is this an if statement for the logic of the program? If we use try catch blocks, we know those are only for exception handling. Alright, so here is an example of fixing that miles per gallon problem. Because how many people are going to enter 0 there? Sure, some people might. When you're taking in user input, you have to consider the lowest denomination of user. So someone who will make mistakes and needs help doing it correctly. So, some people will do this potentially on accident, make a typo, whatever. And we don't want the program to crash, because people need to know their miles per gallon. They can't just do it on a piece of paper. All right. So they put the code up here in the try block. And so here's the line that we're worried about, trying to divide by 0. If it happens, it will throw an exception. And so here we're creating a parameter of type exception. We're just going to call it E. You can name this. This is the variable you're choosing. Traditionally, you use E for exception. And then inside of here, we're not. You can use information from the exception. They've decided not to use that here, but they're saying set miles per gallon to 0 because then it won't. Well, if they're dividing by 0, I guess it's just going to set it to 0, I guess, so it'll print out 0. I'm not sure they're thinking on that. And then they're going to print out you attempted to divide by 0. And some people will, at this point, will probably say, well, what's wrong with that? Anyway, here's a very, very basic use of this. All right, and then it gets more complicated from here. So here they go, 250 miles, 0 gallons of gas purchased. Kind of a weird way to say it. You attempt to divide by 0 instead of what we saw before, which was unhandled exception, program crashes, it's done. It doesn't, it can continue on and print out whatever. I guess that's why they put 0 in there. So you could see that the program keeps running after the catch block. All right. So the exception class, remember that is the parent class of the system exception and the application exception class. That overrides the toString method, which we talked about in the last class. So here's a bonus question for you. Where did that come from? We did talk about it. And so what this does is we'll take the information in the object and format it in such a way that you can pull out because notice we caught the exception here, but it didn't say anything here about the exception. All right, so in this example, remember we added in the catch block, we add the parameter here of type exception and give it the identifier of E. So this is a variable that is going to hold the reference to the exception object. And here, now we can use this E and use any methods or public methods or public properties that are available. And here they're using the toString method because it told us, well, it has the base exception class has this method, and I'm guessing it's going to use properties of an exception that all exceptions have. And so here we can catch the exception, we can print out the error, and then the program can continue running. All right. So why would you do that? The user doesn't need to see this. Well, maybe for debugging purposes. All right. What about some properties inside of the exception class? So it has a message property, and so I'm sure the toString method prints that out. The getType method, we already talked about that last time. That comes from the parent of all classes. All right, so here they're more specifically printing out the message property, and for whatever reason it's lowercase. Alright, oh, and it's down here. Okay. And so here, instead of showing the entire exception information, it's just showing the actual message. If you remember from the exception, it actually has the name of the exception, the message of the exception, and the location where the exception occurred. Alright, so in this case, the message is useful for the user, so we can just print that out. But we saw you can also make your own message. but sometimes you don't want to have to do that everywhere. Okay. All right. So sometimes you're going to have code that could have multiple exceptions, and we are going to look at the structure of how to fix that. Okay, so within a try block, and this should be obvious, it says only the first error generating statement throws an exception. Well, why do you think that is? The code within the try block basically stops running as soon as it hits an exception. Just like the program stops running if you don't catch it, the rest of the code's not going to run. So it only finds the first one. And then you can just provide multiple catch blocks, and you can use the different exception classes to grab different exceptions and handle them differently. Because certain exceptions are caused by dividing by 0. There are all kinds of other exceptions related to different things. Let's take a look at different exceptions here. So we have the important thing here is to know we still have our divide by 0 problem, okay? And we had a way to fix that just by using the generic exception class. But here we also have an array being set to access the 13th index of this array. So take a look at this and tell me what is going to happen if I try to access the 13th index of this array. Think about it for a second. Okay, what indexes will this array actually have? It only has 3 values, and so it only has index 0, 1, and 2. If I try to access index 13 that doesn't exist, it's going to throw an exception. It'll throw an index out of range exception. And for you people that have been taking the other programming classes, or when you learned arrays in this class, you probably saw this error, this exception, index out of range. And when you see it, if you're using arrays, that's a good place to look. Anyway, this code will throw these 2 exceptions. It's within a try block, and we can add different catch blocks with using the class of that exception to handle them separately, right? So that way, we're going to handle this differently. If it's a divide by 0 error, we need to fix the number or have them re-enter information. If it is an index out of range error, then somewhere, something did not get entered in an array, or a number got put in incorrectly somewhere, and so we don't want that to crash the program. And really, depending on where that information comes from and how it's used is how you would handle it. Here they're just printing out a message just so you can see one thing you can do. And sometimes really you don't even need to do anything other than catch it so that the program doesn't crash. But if it's something you're going to continue to use later, you can use this to prevent incorrect information from continuing on and potentially causing more exceptions. Alright, so I think they got the same code here, yeah. If we run it this way with a try block, it's gonna break on the first line here. We'll never get to run this code. What will happen is it'll get the error on this line and then immediately move to the catch block. The catch block will run, and it'll skip out of the try-catch blocks and continue on with the program. It'll never run this array problem. If we switch those around, obviously it will do that, it'll have an error there, and then it will go down and skip this, and then run this, and then continue on with the program. So it's showing you, this little arrow is showing you basically the flow of how it works. Okay. Here is a case where we can handle the exceptions separately by providing the class name of the exception. You can also use the parent class of just exception to handle all exceptions if you don't really need to differentiate between the errors. And in most cases, you're not going to you're not going to do this. You're going to want to handle those errors specifically, depending again on the situation. That's why these are so generic. The situations where you'll need to do this are literally endless. Okay, it's kind of the point that endless possibilities of exceptions is a small part of why computers can't do everything yet. They can't do everything we can do. Or they can't do things we want them to do, like solve, I'm not sure, solve the game of chess, which would really make a lot of people mad. Okay. So it says, it's poor coding style for a method to throw more than 3 or 4 types of exceptions. That means the method is trying to accomplish too many diverse tasks, and this has to do with something called the singular responsibility principle. And so if you have, and this, a lot of you guys do this, and probably did this in the beginning of the class and other programming classes when you were introduced to methods and functions. Put everything in the main, right? Put everything in your main function. That is the exact opposite of what you should do for a efficiently written program. You should only be using the code you need in the places that you need, and you should not be repeating yourself. And if you do everything in one place, it's a lot harder to debug, because it will have a hard time. If you do everything in the main, it'll say, exception unhandled, it's in the main, but that's where all your code is, so good luck. All right. Unreachable blocks. Why are they bringing this up? Contain statements that can never execute under any circumstances because the program logic can't get there. So that's like having if true, put some code in there, else, put some code in the else block. When is that code in the else block going to run? Never. So that would be an unreachable block. It's pointless to have code in there. I think they're bringing this up because if you handle each individual potential exception, even if it will never happen, you're kind of wasting space, and you have unreachable blocks. I'm assuming that's why that's in here. Maybe they go into more detail in the book. Okay. So there are times when you're taking input from a user and you want to limit the type of input, to either number, numeric, or alphabet, characters, or whatever. So when you take an input, it comes in as a string, you want to be able to convert it to an integer. So you can use this try parse method to take in or pass in the input from the user, and you have this here which will take the number from the parsing, and no, if it doesn't get the number, because here, this right here is really important, this little exclamation point. Do Do you guys remember what operator that is? It's the not operator. And remember, in an if statement, you know that this is going to either return true or false. Or it should return true or false. And so what it's going to do is it's going to say, well, let's worry about the not afterwards, because it's going to run the method here of an int called try_parse, and then you pass this in. And so if it is able to parse, it'll return true. So if it's able to convert it, it'll return true, but the not here will make that false. And so we can skip over this line of code. If it's true, wait, I just said that one. If it's false, so it's unable to parse, instead of throwing in an exception, it will return false, and then the opposite of that will be true, and it will run this. So basically it's saying if they put in something other than in a string value that can be converted to an int, they've lost their privileges of providing that number, and they're going to have to use the default value. So you have to hold their hand in this case. All right. And then this is kind of you might need to use this a lot, so it's kind of shorter than a try-catch block. This is what it would look like if you just made your own. So it's a lot longer. But this is already created for us in the method. So all we have to do is call it. All right. So let's say you have an exception. You try the code, you have an exception, and then you catch it. You have some stuff that happens. Do whatever you need to do to catch and handle that exception. But let's say you want to run some additional code if there was an exception. Okay, I'm thinking of something else. The finally, you can include in a try-catch structure at the end a finally block. And so it says inside of this you can put code that can help you clean up. So you can use other classes and methods and whatnot. It's just a block of code. Okay, so if there is no exception, it's going to run the code in there. If it catches, and it'll happen no matter what. It's always going to run, unless no, never mind. Okay. Even if there is an uncaught exception within one of your exception catches, it'll still, and if that's handled, it'll still run the finally code. Okay. So here's an example. Just of the structure with no code. Try, catch. Remember, you can have multiple catches. Try, catch, and finally. All right. You can't have more than one finally in one thing. When you do something that's final, you're done. It's the last thing you do. That's why it's called finally. So finally, everything's done. This will be the last thing I do. All right, here's some more examples. Okay, and then they're using some really high-level pseudocode here to create an algorithm. Open a file, read a file, place the file in an array, place the data from the file in an array, yada yada. So here, since we're reading data from a file, that's input-output, or actually we're reading and we're just opening and reading a file. I guess we're not writing to one here. That's input-output, and so it can cause an input-out exception. So they have that here. Give an error message, and then exit. This is redundant. I guess if you didn't know, when a block of code reaches the end, it exits that. So there's no extra thing you need to do here. And then regardless of what happens, it's always going to do this finally, close the file. So in this case, if you have a file open, what occurs in the computer is, it's going to create an object to hold the information about that file and including the information in the file. It's going to store that in memory. So if it's a large file, you are now taking up a significant portion of memory, potentially, and that's going to stay there until you close the file, or the block of code that that opens that file closes, and then remember that object will have no longer have a reference in whatever scope you're in, and then the garbage collector can pick it up, which we talked about before. Okay, so in this case, they're closing that open file. That'll manually free up the memory that is using as soon as you are done, instead of waiting until whatever the program ends, right? So can help you prevent file opening memory leaks and those type of things. Okay. Handling exceptions thrown from outside methods. All right. And so here's they're saying, oh boy, we're using object-oriented programming. It makes exception handling a lot easier. When methods from other classes throw exceptions, those methods do not have to catch them. You can catch them at the level of wherever you're calling it. So what does that look like? Well, here we have a class of price list with a method of display price. Okay, so you pass in the item number you want, and then it's supposed to print out the number, the value of that item. So for example, if you pass in 1, it's going to return the price is $15.99. I mean, it's not labeled, but we take it for granted that US dollars are what we're talking about. I guess it doesn't matter in here. All right. So what kind of error do you think this could potentially happen here? It's an exception we already talked about. We're taking in user input. We're not dividing, but what are we doing? We're accessing an array, so we could have an index out of bounds, or index out of range, whatever it's called in this one, in C#. And so this code here does not handle that exception explicitly. And we don't have to worry about that inside the method, because wherever we're using that display price method, so for example here, we are asking the user for an item number. Oh, and we're also converting it to int32. So if they put in A, it's going to give us another error, but that's not what they're showing here. When we call that display price, it'll pass in whatever they enter. So let's say they enter 13. There is no value at index 13. It'll throw an index out of range exception. But we have that here in a catch, and we can print out the price is 0, I guess, instead of, there is no item 13. Okay. And again, the point of this is to show you, even though the code is coming from another method, since it's in a try block, if this method throws an exception, it's going to pass it up to the next level wherever you're calling it, and then your try block can catch it and you can handle it. All right, here, let's see, is this the same thing? No, it's a different one, but it's doing a lot of the same thing. Okay, here we go. So this is a much better message. If it throws an error or an exception, it says you must enter a number less than 4, and then please re-enter the item number. Okay, and since it's in a while loop, it'll go back and run again. And if they put in a correct number, it will get to this part down here where it says is good item equals true. And so when it gets down to the end of the while loop, it'll go back up to check is good item true, but then the opposite, so it's only going to stop when good item is true, because we are using the not operator here. Okay, because that's when we want it to stop, is when they've entered in a good item, and then they can print out thank you. So anyway, here's what it looks like. Type in 12, and you guys can type this code in Replit, and it's a good example to pull from because it works. If it doesn't work, sometimes these have syntax errors in the book. It's like, okay, you're making a textbook about programming. Maybe you should try the code before you print the book. And anyway, I don't like textbooks. They enter 12. Hey, that doesn't work. And re-enter the number 4. So this is that user I was talking about, that lower denomination user that's going to need help. So enter an item number 12, and then enter a number less than 4. Oh, I see 4. Let's put that. No, enter a number less than 4. Calculating 3. That is a number that's less than 4. It worked. The program didn't crash. The user didn't get too aggravated, probably. Not as aggravated as if it just crashed. Okay. Wow, we still have a lot of time. Cool. Do we? No, we have till 12:15. So we have 20 minutes. All right. Call stack. Tracing exception objects through the call stack. The call stack is very important to understand in programming. So this is the idea of understanding. It goes with variable scope. It goes with understanding the flow of a program and understanding what is currently in memory, what is not. All right, and this tracing the exception through the call stack, this is basically how outside methods can throw an exception and your code can handle it. So I can do a little thing here. This will be easier with a picture. Call stack. Any of you are Magic the Gathering players? This may look familiar to you. OOP2. Whoops. Is it going to let me save it? Yes. Okay. Awesome. And why didn't it put a name in there? Call stack diagram. All right. So let's take a picture of this code from the PowerPoint, and we'll take a look at what the call stack looks like for it. All right. Let's use this for our example. All right, take this code. All right, so when you execute the program, it's going to run main, and so in memory, the highest level of the call stack for this program is, can I set this to the top? Oh, maybe it's in here. Align top. Is it up here? Oh well. I'll just have to complain that it's in the middle until I can find where that is. Alright, so here's our main, the main method being run from the main. Here's our main method from our price list application 2 class. So we start the program, this opens up, you know, it's created in memory. It's going to create a variable called item, store 0 in there. We're still in the main here. Variable here, we got a while loop. And so we could have a block here, and you can consider this being inside the main here. This is our while loop, okay? And then inside of the while loop, we have our try block. So that's another thing added to the stack. Try catch stuff. Okay, and then inside of the try, they're calling the console.writeLine method here. So that would get put on the call stack, but then immediately once it's done running, it's done. Here we are using this convert to int method. So that would go on the stack and then that would resolve. And then here we would put the price list display price item. That would go on the call stack because it's a call to another method. And so the program can't keep running until that's done. Display price method. All right, and then if it throws an exception, so at this point we are doing something like this. Directional connector, we want this. Okay. I just want a line. I guess I don't want it to be a connector. All right, so the main goes into the while loop. There we go. Okay, and then let me see if I can just use a line. That'd be better. Shapes, miscellaneous. Okay, we want an elbow. Like this. Alright. So the main, inside the main, we have this while loop. Dang it. That's not going to work. Arrows. Here we go. That'll work. Alright. Whoop. So the main, inside the main, we call the while. Inside the while loop, it has that try-catch block, and then the try-catch block within that, it opens display price. So the main is waiting for to continue while the while loop runs. So it's waiting. It's not doing anything. Once we hit the try-catch block, the while loop stops and won't continue until this is done. And within the try-catch, it's opening and closing things on the stack. But once it hits display price, we have the potential for an error. at least as described in what we looked at. And so the try code is waiting to run until display price is done. And then as soon as, let's say they enter in the correct information, display price will be done. Then we can continue running the try code. Once that's done, we can continue running the while loop. Once that's done, we can continue running main. Okay, so we have this stack. We're taking code and we're putting something new on top of the stack, and then whatever's on top has to finish before we can go back and finish the next step and finish the next step all the way down. And so while these are waiting, all the whatever you've created and whatever you're using is just sitting there waiting before it can do anything. So it's taking up space in memory and yada yada. Anyway, let's say they do put an error. The display price will throw an exception, and that will go to another one here. And I think my arrow is too big for this, so let's get a smaller one. Here we go. All right. Because it throws an exception, it is going to go into the catch that we've defined for that. And so in this case, we're catching index out of range. So if this display price throws an index out of range exception, the display price is done at that point. It's not going to keep running, and it will go back and say, I failed because of this exception. Pass that up to the next function that's waiting, and then that function will check, do I have a way to handle this? If I don't, pass it up to the next function. If that doesn't have a way to fix it, program crashes. Okay, so this is because we have a try catch block. Where did my arrow go? Lost my arrow. Okay. Let's flip it around. It'll come back here and use the appropriate catch, and then, you know, if it has a finally, it'll do that. But once that catch is done, the rest of the code, or once the catch is done, it'll go back up again and continue the while loop. And then once the while loop gets a value that of false in the condition, it'll stop and it'll continue in the main. All right, so this here is an example of what's happening in terms of the code stopping and starting, and then the call stack is kind of more focused on the actual functions, but I didn't want to have just two in there. So anyway, if you don't understand this, diagram, what I'm trying to show you is how, you know, the flow of a program, and at this point you really need to understand that. So the way you read this code, you got to read it like the computer does to understand, you know, well, you have to write it so the computer understands it. So if you can't even understand it, how are you going to make the computer understand? So you know, obviously when you hit a while loop, you're going to be stuck there running this code over and over again until the value is false. So you don't even need to worry about what's after it until you get this figured out, or whatever you're doing with that. And then whenever you call a method, understand there's code written somewhere for that method that will run when you call it, okay? It's not a magic button that you press and it does what you want, even though it's designed in a way that as long as you know what the input-output of a method is and it works the way you want, you really don't need to look at the code inside. If it's not doing what you want, you could extend it and add those features or write your own class. And then you know exactly what it's doing because you wrote it. Okay. For example, WriteLine that we're using, that's a method of the console. You probably find the code that runs that method, but we can easily just take it for granted that it's going to print out to the console. So we don't need to know that code. So it seems like a magic button, but it's not. It's just using the same code that we write everything else in. Okay, anyway, pulling back the curtain. Hopefully the curtain's pulled back for everyone. All right. So, call stack, the memory location where the computer stores the list of location to which the system must return. So every time you call something, it's adding another layer to the stack, and it cannot continue on until it completes that layer. Once the layer, and so it keeps going down until it runs out of calls, then it moves back up. All right. If a method throws an exception and that method does not catch it, the exception is thrown to the next method up, like I described, and that's called propagating the exception. So propagation is, creating more of something. So like propagating plants is planting more, getting the seeds, planting more. So it's creating the exception higher up so that that method could try to handle it. So we have this stack trace property that contains a list of methods in the call stack so you can determine the location of the exception. And so here they are trying to access index 2 of this tax rate array that holds doubles. So it only has index 0 and 1, so it's going to access 2. It doesn't exist. It's going to be an index out of range. They're adding more to it here. And then here's where they are adding the exception handling. So here's our try catch block. So when it calls that display price method, we're passing in the item number if it's wrong. And what are we printing out here? It's just printing error. So that's what's happening here. This one is this one back here. Well, this was the original one from before. Well, they're just printing out the exception error. So when again here E, that is the exception. Remember, and I see in the code they've named it error and they've named it E, but you choose the name of it here. Okay, so here they're accessing the message property of the error to show index was outside the bounds of array. All right, and then down here, they are accessing the stack trace property of the error, and it shows basically the methods and classes that were used to get basically the path where the error came from. So it says here they're trying to access, what do they call it? Tax rate. Okay, determine tax rate method first, and that is here. Determine tax rate, and the code for that is right back here. Determine tax rate. This is where the code is going to try to access an index that doesn't exist. I like how they say don't do this, as if they don't have errors in their code that aren't labeled. Okay. So inside the tax class, we have determine tax rate. And so it's saying, hey, in the tax class, determine tax rate through an exception. And then that went up to the price list class's display price method, was not handled there, and then it got all the way up to the main, wasn't handled there, crash. All right, so that's the stack trace that you can take a look at. So if you've been seeing those and you're not sure how to interpret it, this is how you interpret it. We got classes and methods telling us exactly where it's happening. And so we could handle it in the determine tax rate method. We could handle it in the display price method, or we can handle it in the main method. And that's, there are different reasons to do it in different places. All right, so let's say you want to create your own exceptions. And it's 12:15, but I only have a handful of slides left, so I'll just power through. All right, how to create your own exception. So we know that we have an exception class that has, pretty much everything we need for an exception. So all we have to do is create a new class, give it a name, probably related to what the exception is that you want to create, and then we just have to extend the exception. And that gives us all the base tools we need. All right, we are going to provide a static string here to provide a message. For our exception, okay? And the fact that this is static here means that we don't need to Scott.
It means it exists for all objects of the class.
Really? Okay.
Static means that it exists as part of the class rather than the object.
Okay, that's what I thought. So that means every object can use it and you can call it from just the class?
Yes, but it's private and you have to instantiate an exception object, so I don't know why they would make it sound like that.
Yeah, I was confused too. Okay, anyway. They are creating, what is this, the constructor? Because it's the same name here. And then they are using here base message. What that is doing is grabbing the code from the constructor of the exception class. And so we don't need to provide whatever code in here because it's handled in the base class. And so we don't need to retype the code again, so it's in two places, right? All right. So here we're creating a new exception. And so here, let's see how we use it. All right, so in our bank account class, in our set method for balance property, right? If you have a bank account, your balance is, you probably know or keep track of your balance. If you don't, you should. But you want to keep that number above 0 unless you want your account closed, and you really don't want that to go negative, because when you when you don't have enough money to pay for something and you try to pay for it, the bank says, okay, you're going to have to pay us more money, but you're already out of money, so it's bad. All right. Anyway, when you set the value So you're saying, okay, we're updating the bank balance for someone, or create or if the value is less than 0, which is bad, you will create a negative balance exception object, and then we'll throw it. Okay, it's not nice to throw things, but in programming it is. New negative balance exception. This is one line right here. Negative balance exception, and they're calling it NBE, that's the identifier for the object, equals a new, so we're instantiating an object from the negative balance exception class. It's calling the constructor here, which back where we defined it, is going to call the base constructor and pass in this message of the negative balance exception. So it's going to call the constructor from the base class, which is exception, because we're extending it from exception. All right. So inheritance is not going away. You have to understand it. So anyway, they're checking if the value is less than 0. If it is, create an exception, and then you throw it. Okay, and so here, creating a new bank account, they're setting the account number to 1234. So they're creating a new bank account object here, and they're setting the balance to -1,000. Not a good place to start. But they have it in a try block, and they have a catch that will print out the relevant message here and the stack trace for that exception. The point, here's the hard thing in this class sometimes. These programs are purely for demonstration and have almost no real world value. This is not how anything would be done. This is way too simple. It's purely to show you an example of how the code works. So you can plug that in, see that it works, mess around with it, and see what does and doesn't work on your own, or I'm going to show you, a few things. And then from there there's only enough time to show you the basics. And from there you have to learn yourself. Okay. All right, rethrow the exception. What are we doing here? Let the calling method handle the problem. The method that catches an exception does not have to handle it. I think they're going to show us that. Within a catch block, you can rethrow the exception that was caught by using the keyword throw with no object after it. Okay, so here we have a try block, and we have catch whatever exception. We have 2 methods. No, we have 3 methods that main can run kind of at, just as functions. Method A, B, and C. Okay, so they're going to try to write line, trying in the main method, and then they are doing method A. So method A is going to try to write line trying in method A, then call method B. So remember the call stack, we could show the call stack main, and then the try here, and then they're calling method A, so that now method A is at the top. Within method A, I don't have anything in my hand. I can't hold my hands up. Within method A, they're calling method B, so now that's on the top of the stack, and everything we've called before is waiting. And then method B calls method C. And then within method C, again, this is for demonstration, you would never do this. They are just going to manually throw an exception, throw a new exception. This came from method C. That method C on the stack will be done, so it'll pass that thrown exception up to B. That'll finish because we have a catch here that throws that upwards to method A, and then from method A passes it up back to main, and then the program's done. So good demonstration of the call stack and how a exception can propagate all the way from the top of the stack down to wherever it gets handled. And so they keep throwing it. They are catching it and throwing it up to the next one. So you can follow the path, trying in method A, trying in method B. What did they put in method C? Oh, just in method C. Okay. And then they're not catching anything in method C, they're just throwing. So then it gets caught in B, because that's the next thing on the stack. Then the next thing on the stack is A, because B throws that up to A. And then it gets caught in the main method, and then it prints out this message. Again, this is from the catch block of the exception handling, the catch block for handling any exception, because we just have the exception class. And then they have the main method is done. So we have one exception that gets passed up all the way, but since we have catch blocks, it doesn't crash the program. Okay, so that is basically it for exceptions. I know you have that all memorized now. You'll be able to use it without any help. Now, seriously though, if you need help on this or any previous assignments, do check out my schedule. I'll post it in the announcements. You can sign up for times, and I can give you some one-on-one help. If you have simple questions, you can always email those to me. You're not on an island. I know we're all quarantined away from each other. I don't want us to group up, but we can easily do a one-on-one. We can share screens, and I can walk you through stuff. I will make you understand it, okay? Because if you don't, it's going to be really hard to get a job, and that's what I want for you. Okay. So that's it. I will see you next week. Again, please contact me if you need help. Have a good day.